Hello children, welcome back to my channel. I am now dealing with 10th class maths, tangents and secants to a circle. In the previous class I have done about some introductions, example problems and some one construction also. Now one or two I think. Now I am going to do exercise 9.1. In this exercise 9.1 you are having first question is fill in the blanks. You need to fill in the blanks. So let me write the answers here. The first question is a tangent it should be a tangent to a circle touches it in a dash points. Tangent to a circle means, see, this is a circle and this is a tangent. I have already given you explanation about the circle and the tangent. It is touching at only one point only. This is the point P where it is touching. Next, the line intersecting a circle in 2 points is called. See, you have got a circle here. This is the center, this is the line which is intersecting the circle at 2 points. Then what do you call it? We call it as a secant. This is tangent, this is secant. Then the number of tangents can be drawn to a circle parallel to the given tangent. See, you have got a circle and a tangent parallelly to a given point. How many you can draw? 2. So we'll write it here as two parallel lines you can draw. Next, a common point of the point of a tangent to a circle and the circle. See, this is the circle, this is tangent. A common point. This is called as point of contact. The answer is point of contact. Next, we can draw dash tangents to a circle. I have already explained. See, a circle means it contains a set of infinite number of points. From every point you can draw tangent. So how many tangents you can draw? We can draw infinite tangents. Countless tangents. Next, a circle can have dash parallel tangents at most. How many? Even that also. See, a circle has got many points, so many lines. In that, many parallel lines. So here also you can write infinite. Parallel tangents at the most. So these are the answers, children. Please note it down. Then I'll go to the next part of the exercise. Now, second sum, children. Second sum is a tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at a point Q. So that OQ is 13 centimeters. Find the length of PQ. So, you have got a circle with center O. Let me take this as point P. So, the tangent, so this is the tangent. Okay. Now, the tangent PQ at a point P of a circle of radius 5 centimeters. So, this is the radius, this is 5 centimeters. Meets a line through the center at a point Q. Means through the center a line is drawn. This is meeting the tangent at a point Q. Okay. Now, so that OQ is 13 centimeters. This OQ measure is 13 centimeters. Then find the length of PQ. What is this PQ? X centimeters. That they are asking. So, we'll say that in triangle OPQ, angle P is 90 degrees. Why? Because tangent is perpendicular to radius. So it is 90 degrees. Therefore, what you can say, OQ square is equal to OP square plus PQ square, basing on Pythagorean theorem. It means we need what we need? We need PQ length. We need PQ. So PQ square will be equal to OQ square minus OP square. This OP when it comes here minus. So what is OQ square? It is 13 square minus what is OP square? OP is 5 centimeters. 5 square. So A square minus B square. That means A plus B into A minus B. This is very easy for you to do, children. 13 plus 5 is 18 into 13 minus 5 is 8, isn't it? 18 into 8 plus 5 is 13. So what is PQ? PQ is root of 18 into 8. So the most convenient method I am teaching children, here 18 is there. So go for prime factorization. 2 nines are 3 3s are. So you'll be writing 18 as 2 into 3 into 3 and 8 as 2 into 2 into 2. You know that 8 means 2 into 2 into 2. So here instead of 2 values we'll take one out now. So 3 into, see, these two 2's, 2 into again 2. So how much are you getting? 3 2s are 6, 6 2s are 12. Therefore PQ is equal to 12 centimeters. This is the answer. When you do the calculation in this way, children, you will find it very easy to find out square root. Otherwise, if you multiply, actually the other method is 13 square 169 minus 5 square 125. Subtract it, find the number, use the square root by division method or prime factorization method and do. Even that is another method. But what I prefer this only because a square minus b square, a plus b into a minus b. Whichever number let them give. This is the easiest way of doing, I feel. So I'm teaching you in this way. Please note it down. This is second problem. Third question, children. It is draw a circle and two lines parallel to a given line drawn through outside the circle such that one is tangent to the other and one is secant to the other. What is that? They have asked it to draw a circle and two lines parallel to a given line drawn outside. So you are drawing a line outside. This is L is the line drawn outside. And for this parallel lines you have to draw. How? One outside the circle such that one is a tangent to the circle and another one is secant. So you can keep a point here. It is, you can consider it as a P so that you can draw a line parallel. See children, parallel line you can keep a scale like this and then draw a line. Definitely this will be parallel because parallel construction we need not do it here. So see, this is P is, yeah, this is L, this is M. This is the tangent. And another one which is parallel to M and or parallel to, if it is parallel to M, automatically it is parallel to L. That in such a way that it is a secant. So N. N is a secant. So this is the solution for this problem, children. So here L is parallel to M is parallel to N, and M is a tangent. Point of contact. Point of contact is P. P is the point of contact. Then you can say that Q and R, these are the points. N is a secant. It intersects the circle at Q and R points. So this is the solution of this problem, children. Please note it down. It is third one. Now, fourth problem, children. Calculate the length of the tangent from a point 15 centimeters away from the circle. So, let me draw this. Let us consider that this is a circle and center O, and there is a point P which is 15 centimeters away from the center. So, this is 15 centimeters. And tangent, let me take a point here Q and draw a line through this point. This becomes tangent. Now let me join Q and O. This is the radius. Radius is how much? Calculate the length of the tangent 15 centimeters away from the 15 centimeters away from the center of the circle of radius 9 centimeters. This radius is 9 centimeters. Now we need to find out the length of the tangent. So in triangle PQO, angle Q is equal to 90 degrees. This is 90 degrees. Why? Tangent is perpendicular to radius. Basing on this property, we will say 90 degrees. Therefore, OP square is equal to OQ square plus PQ square basing on the Pythagorean theorem. The problem is same as that of the earlier one, means children, only calculation part you will get it. So you want PQ square is equal to OP square minus OQ square. OQ, when it goes here, it becomes minus. OP is 15. 15 square minus OQ is 9 square. So A square minus B square, A plus B into A minus B. So 15 plus 9, 14, 24 and into, and this is 15 minus 9. How much? 6. 6. So what is PQ? Root of 24 into 6. That is equal to root of, let us take 24 prime factorizations. 2 ones are 2 twos are, 2 six are, 2 threes are. So you are getting it as 2 into 2 into 2 into 3. And 6 means 3 into 2, 3 twos are. So here this means instead of 2 twos I am taking 1 two out, and instead of 2 twos 1 two out, and instead of 2 threes 1 3 out. So 3 twos are 6, 6 twos are 12. 12. Therefore PQ is equal to 12 centimeters. He is asking to find the length of the tangent, so tangent PQ. So length of the tangent PQ is equal to 12 centimeters is the answer. So please note it down. This is fourth problem, children. Now fifth question, children. Prove that tangents to a circle at end points of a diameter are parallel. Very important question, children. So you have got a circle with center O. Now let me consider this as a diameter. This is center. The diameter, let me take it as P and Q. So when I draw a tangent at Q, this is tangent at Q, and tangent at P. Let me call this as L and M. So what we can say, what is given? You have got A circle with center O and PQ is the diameter and L tangent L is drawn through P and tangent M is drawn through Q. Now this is given. Now what is RTP? What you need to prove? We have to prove that L is parallel to M. So let us see the proof. What is the proof? We know that PQ is perpendicular to L. PQ is perpendicular to L. Why? Because diameter is perpendicular to tangent. Radius is perpendicular to tangent means diameter also is perpendicular to tangent. Therefore, I can say angle P is equal to 90 degrees. Here angle P is equal to 90 degrees. Similarly, angle Q also is 90 degrees. You need not write again everything. Angle Q also is 90 degrees. So, angle P plus angle Q is equal to 90 plus 90, that is 180 degrees. Angle P plus angle Q, 90 and 90, 180 degrees. But what are they? They are interior angles on the same side of the transversal. What is transversal? PQ. Why is it I am saying? See, these two are parallel lines means this becomes the transversal definitely. And in the transversal, if a pair of interior angles, if the interior angles formed by the transversal on the same side, see, both of them are on the same side, either you take this side or this side. If they are supplementary, that means if their sum is 180 degrees, then definitely the two lines are parallel. So we have got it that interior angles on the same side of transversal are supplementary. Their sum is 180 degrees. Therefore, we will be saying that L is parallel to M, hence proved. We have proved. It's a very, very important some children you are going to get in the examination. Please learn it properly. Now, a very, very important theorem, children. Theorem 9.2. The length of the tangents drawn from an external point to a circle are equal. Very important theorem, children. Many times repeated one. So you have got a circle and this is center. Let me call this as P. 2 points I am taking, Q and R. So let me join PQ. So here it is Q and PR. So R. So this PQ is one tangent, PR is another tangent. Okay. Now here what you need to prove, you have to prove that PQ is equal to PR. So what is given to us? We have got a circle with center O. This is O. center O, and we have got PQ is a tangent, okay, and PR is a tangent. This is given to us. Now, what is RTP? You need to prove that PQ is equal to PR. Here, you have a construction. What is the construction? Construction is you have to join PQ, OR and OP. Join PQ, OR and OP. This is your construction. Now proof. See, when you join them, you are getting two triangles. In triangle PQO and triangle PRO. See, PQO, PRO. In these two, angle Q is equal to angle R because they are 90 degrees. Angle Q is equal to angle R 90 degrees. Why? Tangents perpendicular to radius. This is the reason why we are saying that they are equal. These two are equal because they are 90 degrees. What is the reason? Because tangents are perpendicular to radius. And then what else we can say? OQ is equal to OR. They are radii. Radius is singular, radii is plural. We are talking about this. OQ is equal to OR. They are radii. And OP is equal to OP. Line segments, so draw like this. Common. Both of them are having common side OP. Therefore, triangle PQO is congruent to triangle PRO basing on RHS property, right angle, hypotenuse, side property. When these two triangles are congruent, then you can say that PQ is equal to PR. Therefore, hence proved. This is how we have proved that the tangents drawn from an external circle are equal. So this is the proof for this theorem, children. Very, very, very important essay type question it is. Learn. Construct a tangent to a circle from a point external to the given circle. So suppose this is the circle given to you and this is the center O. And a point is given here P. You have to draw a tangent to this point. Let me take the point exactly. It is convenient for us. So I am taking this is the point P. Now from this point you have to draw tangents to the circle. First what you have to do is you have to join PQ. So construction, no? So join PQ. After joining PQ, you have to draw, for your convenience sake, you may find it difficult. Let me draw a line. So join PQ. After joining PQ, what you need to do is, you have to draw the perpendicular bisector of PQ. How will you do? More than half of OP has radius, P as center, one arc here and one arc like this. Slippery, children. I may not get it properly, but construction, you see how it has to be done. More than half you have to take. More than half means, see, this is more than half. So with this, more than half of the radius, draw an arc like this as well as an arc here. After drawing it, without disturbing it, O as a center, you have to draw. See, actually this instrument is not functioning properly. So, I'll be doing by hand, children. Just by hand I'll be teaching. I have told how you have to do. You take this. More than half you have to take, one arc this side and one arc this side. Suppose I have got two arcs in this way. One arc here, one arc here. Without disturbing it, O as center, you have to cut these two arcs. This instrument is not functioning properly, so I'm just doing it by hand. But you please don't do like that. You have to do using instrument. So now this is the line that you are getting. This point is called as, let me call it as M. What is this? This is the midpoint of OP. Now what you have to do is, again I am showing but I'll draw. See, M as a center, M as a center and MP as a radius. M as a center, either MP as a radius or you can take MO as a radius. Anyway, you have to draw a circle like this. From here the circle should go like this. So I cannot use my instrument. So I'm just drawing the circle. So you will be getting somehow in this way. In the broken line, you can draw the circle. The circle goes like this. So you will be getting a circle like this. When you get a circle, you do it by using instruments, children. This circle is intersecting the given circle at 2 points. Okay, let me call it as A and B. At 2 points, these two are intersecting. Then you have to join A and P and P and B. These two are the tangents to the given circle. So you do it with your instrument, children. You will get this circle properly because I have not used the instrument. Maybe it is looking little bit crooked, but I hope you have understood the method. Now let me teach you about the steps. What are the steps? First one, draw a circle with center O. Second point, locate a point P outside the circle. Outside the circle, you have to locate. You have located a point. Then you have joined PO. After joining PO, draw. Let me call this as X and Y. Draw XY, the perpendicular bisector of PO. Perpendicular bisector of PO. PO, XY. XY intersects PO at M. This is the point, at M, XY is intersecting PO. Next, second point, sixth point, M as a center, MO as radius, draw a circle. Seventh point, the circle passes through P. The circle passes through P. Eighth point, the circle intersects the given circle at A and B. Ninth point, join AP and BP. 10th point, AP and BP are the required tangents. Now children, if you want to prove it, you can even write the proof. How will you write proof? You have to join O and A. First you have to join OA. And angle PAO is equal to 90 degrees. Why? Because it is angle in the semicircle. Yes or no? So this is diameter for this circle. Then angle in the semicircle is always 90 degrees. Therefore, tangent or therefore I'll write PA. Therefore, PA is perpendicular to AO. Therefore, PA is a tangent. So this is the proof, children. First you write these steps and then you write the proof afterwards. Second, after writing the steps, if you write proof, proof will give you a clear-cut understanding that yes, we have drawn. Here we can even say that similarly, this is the symbol for similarly, PQ is PB. PB is also a tangent. Similarly, you can prove that PB is also a tangent. This is the symbol for similarly, children. So I hope I am clear. This construction is very important. Please note it down. Do the construction, children. I am unable to do with the instruments. So this is also very slippery. If I keep it to the center, it is moving out. So it's not possible with the instrument to do it. It's a big construction. That is why do it in your notebook. I hope very clear. I'm very clear about how the construction has to be done. Do it by yourself by observing this. This tangents construction is very, very important as a type question, children. You have got constructions in the triangles. You have done 2 by 3 part of the given triangle, like that 1 2 by 3 parts of the given 1 by 3 parts of the given triangle. Like that you have got various constructions which you have done in similar triangles. Now this is the tangents and secants. In this also you have got this construction of the tangents to a given circle from an external point. These are very, very important constructions. If you learn them well, steps, it's of course what you have done, you are writing that. There is no problem in writing the steps. And proof also I have explained. Please learn it perfectly well so that it will be useful for your examination. With this, I am concluding my part. In the next class, I will be doing the next part.